Hello everybody, welcome to my channel. Today we have an amazing problem for you guys, right? It's called container with most water, right? So this is a very good problem, and I can personally say it's one of my favorite problems in all of LeetCode, right? So this is a very good one. So let's see what it's all about, right? So it says an integer array of height, right, of length n, right? There are n vertical lines drawn such that the two endpoints of the eighth line are I of 0 and I of height, right? So pretty much what they're saying here, right? We're given an array of integers, right? For each index, right, it represents the height of that, the height of that line at that particular index, right? So that's kind of what they're saying here, okay? It says we need to find two lines that together with the x-axis form a container such that the container contains the most water, right? So, okay, they're asking us to find two different lines, right? Meaning you have two different index such that the height is maximum, right? So the maximum one, right? Return the maximum amount of water that can be stored, right? Okay. Notice that you may not slant the container. Okay, interesting. We can't slant it. Okay, so it has to be like that. All right, makes sense. So let's go through a couple examples, see what it's all about, guys. Right. So we want to further solidify what they're asking us to do, right? So we're given this height, right? We got a bunch of lines, right? So like I was saying earlier, right? Each index, the value at each index, right, represents the height of that line at that particular index, right? So we have one is only a height 1. The second index has a height of 8. That's why it's one of the tallest ones, probably the tallest. Yeah, one of the tallest ones, right? And yeah, things like that, guys, right? So we can see that we were able to find the tallest one for this one, right? It's this line and that line, right? So by combining the two, right, this is how we get the maximum area, right? So how we get the area is calculated by the width times the height, right? So the width is calculated by the distance, right? The length of this, right? Of the two index, right? And the height, right? The height, how do we get the height? Height is bounded by whichever one's the smallest one, right? So this is a very important aspect that I want you guys to remember when you guys are continuing this problem, right? So the height of whatever line that you're combining together, right, it's bounded by the shortest line, right? Shortest line, right? Because if we were to choose the tallest line, right, then water would go over, right? So we wouldn't be able to store it, right? That's why it's bounded by whichever one is the shortest one, right? And that's how we know that for sure that the water is going to be able to be contained in there, right? So we know we get the minimum height of 7, and the width is also 7, right? That's why we end up with 49, right? Okay. Yeah, right? So what's next for us, right? We see that this one is pretty simple. So we just get a height of 1, right? So how can we go ahead and solve this problem, guys, right? It's kind of what we need to ask ourselves, right? How can we solve this problem, okay? In this channel, we always like doing things brute force, right? Brute force, doing things, not a clever way first, and then optimize and see how we can be smart and be clever, things like that, right? So since we're looking for some kind of a combination of things, right? I mean, we're looking for two lines that, that can be used together to form the maximum one, right? So like I said, we're doing brute force. So brute force, thinking, my intuition will say to try every single combination, right? So a nested for loop, right? 2 for loops, right? We would do a nested for loop, right? For each index, we calculate the area for each combination, right? So for example, we start here, we try every single one, right? You'll try, okay, what's the height, what's the area for this one, for this one, for this one, right? And then we try all combinations for this one, then we start over right here, right? And then using this line, calculate the area for each combination, right? And like that, and this will be like, pretty easy, right? And then we'll have a variable that keeps track of the maximum one, right? And then we will return, and we would be in good shape, right? But as you can tell, right, it's n squared, that's not efficient at all, and that's not very efficient. Yeah, so that's not very good. So we need to kind of improve the time complexity, right? Because n squared, that's not going to cut it, right? Can we improve it by introducing memory? Can we do it by using some kind of other technique that we know of, right? maybe we could start using some sort of a two-pointer, right? You know, so we're looking for a combination, right? We're looking for a combination, right? So how about we start off taking in the biggest, so the two different lines, right? You know, so so the two different lines, which will be the beginning of the array, right? And one that would be at the end of the array, right? Okay, following so far. So we use those two lines because those will give us the widest width, right? Which is what we want, right? So this would help us in maybe potentially get the maximum area that we can get, right? So that's why we start off with those two extremes, right? Both ends of the array, one at the beginning, one at the end, right? And then we calculate the area for those two, right? Okay. And once we calculate the area for those two, okay, we store that, right? We get the area, right? And then we keep doing that, right? So now we're gonna be saying, what do we do next, right? How do we know to move? Do we move both at the same time? Do we move one at a time? What do we do next, right? So you guys understand the part where we use the maximum one, right? The two extremes, right? How do we know which one to move, right? So we need to move one of them, right? Not two, not both of them at the same time. We need to move one, but which one? We should move whichever one's the shortest one, right? We're we're moving the shortest one because we want to get the maximum height, guys, right? So if we move the ones that's the tallest one, right? And then so now not only that, the width is getting smaller, right? Because one of them is moving because we're moving inwards, right? The width is getting smaller, but also when we end up calculating the height, right, of whatever, say we find a taller one, right, a taller line, right, it will still be bounded by the shorter line, right? So this would not help us to improve at all because we're shrinking the width and the height will still stay the same, right? That's why we're saying that we're not gonna move the pointer that's pointing at the taller height at the moment, right? We're not going to move that, right? We're going to move the shorter one because the shorter one is not going to help us in yielding the maximum area, right? So let's go through a couple of examples. I think it will be a lot clearer, right? So quick example, right? So how the approach would work, right? So the example that I was saying earlier, right, guys, right? So this is a pretty simple example. So we're just gonna do a quick walkthrough real quick, right? So we would calculate the height for this one, right? This would be so the area is calculated by width times height, right? So the height of this one would be of this one and this one, right, would be of height of 1, right? Because like I was saying earlier, right, it's bounded by whichever one the shortest one, right? And I explain why, the reasoning why behind it. Okay, so now the width is going to be 8, right? So now, so turbo 8, by the way, we have a area of 8, right? So our maximum area so far is 8, right? So now I told you guys why we end up moving this one, the shorter one, right? Because if we move this one, right, because we move the shorter one, right, because we want to find ones that will be maybe we could find a taller one than this one, right? But we know that if we move the taller one, we know that it's not gonna serve us any benefit. You know what I'm saying? So that's why we end up moving this one, right? So let's go. So what's next for us is that we move the shorter one and we calculate the same thing, guys, right? We do the same thing. It's the height is what is bounded by the shorter one, right? So it's a height of 8, height of my bad 7, right? Times the width will be 8 minus 1, and that's 7, right? And that's how we end up with the 49, right? Which is better than this one that we have, right? So the max now is 49. That's what we end up with that, right? So this is how helpful it is, right? So now we would continue the algorithm as such, right? We would see which one we need to move, right? Since this height is taller, right? We move this one, right? Because we never know, might end up finding one that's taller than this one, right? But we know this is the tallest one, so let's keep going, right? And then we know this one's not gonna be good, right? And then we calculate this one, we do the same calculation, guys. We get the height. So they have the same height, right? Which is fine, right? They have the same height, which is a height of 8. And we times it by what, right? So now this is 6 minus 1 is 5, right? And then that should give us 40, right? But 49 is bigger than 40, right? So we know that for a fact that 49 is the thing, right? And then we would continue the algorithm like using the same approach that we said earlier, right? And that's how we would be able to solve this problem, guys, right? We would have a maximum variable that would keep track of the maximum one, right? So I think the code will be even more straightforward than how I just explained it, guys, right? So let's quickly go into the code, right? Hopefully you guys understood the walkthrough that I just did. So let's quickly go ahead and get into it, guys, right? So at the left, go to 0, right? So 1 at the beginning and 1 at the end, right? Okay. Okay. So now we're going to introduce a couple variables. So max area. I initialize that to 0, right? And then we have a while loop. Okay. So while the left, then cross over to the right. All right. We're gonna calculate the width. Okay. The width, I told you guys, calculated by doing the right minus left, right? And the area will be calculated by doing the width, right? All right, we just got the width, and we know that the height, right, is bounded by the minimum of either the what the left pointer is pointing at or the right, guys, right? And I explained why. So hopefully you guys, make sure to let me know if I explained it well enough, so that I know to improve it for you guys. Make it more tailored, right? Okay. So what's next for us is to make sure that we keep track of only the maximum one, guys, right? So it's either the current max area or the area that we just calculated, right? With the two different lines that we have, that the left pointer is pointing at and the right pointer is pointing at, guys, right? And then we return the max area, right? So let's see, looks good. So what we need to do, right? So you might say, when do we move the left pointer, right pointer, right? We said that we'll be moving the, whichever one has a height of, as a smaller height, right? So if the height of the left one is smaller than the right one, then we end up moving this one, right? Else, we move the right one, right? So if the left height is smaller, then we move the left one. Otherwise, the right one, right? So it looks good to me. Press run code, let's press submit. Awesome, guys. We're going to pass all the test cases, guys, right? If you guys found value and you guys enjoyed this video, let me know that in the comment section, right? If you guys are new here, subscribe, and yeah, I'll see you guys in the next video.